some stuff I've been doing to test some GUI applications. In the last talk, we saw quite a lot of graphic user interfaces. And one of the problems I find with them is that if they get at all complex, manual testing of them is tricky. We'll talk a bit more about that in a second. But I've also been playing with a library called Guizero, which will actually run on in any Python environment. But it was created by Laura Sack and Martin Hanlon, who both work for the Raspberry Pi Foundation. And there must be hundreds of thousands or millions of school kids and other people who've been building GUIs using Guizero. Laura and Martin produced a book which describes how to use the library, create graphic user interfaces with Python. And essentially that's got a set of games, fun games, with very detailed instructions about how to write the code and how they work. And one of them is what we Brits would call noughts and crosses, and Americans would call tic-tac-toe. Look really interesting. But one of the things that struck me quite early was that although Guizero, the library, has a lot of automated tests, the advice in the book is that you test things manually. And as we'll see, that can cause some problems. So what I'm going to cover, I hope in about 20 minutes, is the way in which you can write automated tests for this kind of application, and also talk a bit about why that might be a really good idea. Out of interest, how many people here have manually tested a graphic user interface? If you can answer in chat, I won't be able to see it yet, but I'd be interested to take a look at the end of the session. And if you have, was it fun? Because for me, it certainly wasn't. The problem with manual testing of almost anything, but particularly for GUIs, is that it's tedious and it's very error prone. And worst of all, you've typically got no automatic record of what you tested and what the result was. And this really mattered to me because when I took a look at some of the code in the book, it was clearly written in a style that was intended to be very, very easy to understand. If you take a look at the aims, they want to make sure that Guizero is something which pretty well anyone can use, but you can still use it for advanced projects. And they've stuck with that approach in the games, which work well and have very simple Python code, but do some things that a professional software developer would look on as a bit dangerous. In particular, throughout pretty well all of the examples in the book, they make quite a lot of use of global variables. And they do warn you that that's not necessarily best practice. But when I started taking a look at the noughts and crosses game, sure enough, there was a global on which the whole game relied. And I started wondering whether that was something that we could easily find a way around. So I started with the code in the book and decided I was going to try and refactor it to change the way the code worked. So change the way the code was written without changing the way that it behaved in the outside world. And that technique of refactoring was first really popularized by a guy called Martin Fowler. He literally wrote the book on it. And the book is very well worth reading if you want to take code that already exists and try and make it in some way better. The problem is that in order to do refactoring safely, you either need to have automated tests in order to make sure that the code still does the same thing, or you need to be very brave. And I'm not very brave. So in order to try and get rid of the global variables from the noughts and crosses game, I needed to start off by getting a set of automated tests. The application itself, I've left most of the code out because it's not particularly relevant to what we're doing, but essentially it creates an application which has information about whose turn it is, and then it has a 3x3 set of board squares in a box, which will be used to hold the noughts and crosses. And you play the game by clicking a particular square, and if it's your turn, the square will then get filled up with the appropriate character. And then there's a message area which tells the player whose turn it is, and will tell you if you've won or if the game's a draw. There are a couple of things about, as I said, I've left most of the code of the game out from this visual because it's not a long program, but it's not a short one either. I've included a method called square, which just gets hold of the push button, which corresponds to each square of the noughts and crosses board, because we're going to use that in the tests. I also mentioned the first snag I hit when I was trying to refactor it. The code they've written has a constructor which creates an application and then tells the application to display itself. And if you do that, the application is untestable. It's untestable because as soon as the app display method runs, it takes control of the Raspberry Pi or whatever else you're running it on, and your tests won't run. And only when you have actually finished playing a game will your code continue. And of course, by then it's too late to do any testing because the application's closed down. So rather than having that happen automatically, I've just said, if somebody is running this particular module directly, then create the game and display it. But if you're simply importing the code from the application, don't run it. The test is going to take care of doing that. So here's the magic which makes the whole thing work. Guizero is an easy to use library for writing stuff. And it's easy to set messages and to detect that a button's been pressed. What isn't obvious is how to achieve the effect of pushing a button from inside a program, as opposed to having a human being do it. But I mentioned at the beginning that Guizero's got a lot of automated tests of the library, and poking around in there, I discovered that buried in it, there's a method you can call invoke, which you can use to tell the button to behave as if a person had just pressed it. So I've defined a method called push, which takes a button as an argument. And when you call push, it's as if a human had clicked the mouse on that button. And that will then do whatever the button would normally do. And then the next thing is a pretty standard unit test. Python's got a unit testing framework built in, which works around things called test cases. I've created my own test case, and this bit of code tells you two things to do. The first, class method, set up class, will only get run once for the entire suite of tests, and it will create the tic-tac-toe application and tuck that away in a class variable. And then for each individual test that you want to run, setup will get run. And the key thing that setup needs to do is it needs to clear the board from the previous test. Otherwise, one test would leave noughts and crosses on the board, which the next test would be confused by. And then there are a couple of helper methods which I wrote to make the tests more readable. There's a very good book which I've mentioned in the resources at the end of the session, which explains that you really need to put as much effort into writing readable tests as you should to write readable code. So I've got a method in my test called message value, which tells you, returns the value which of the message which the application has issued. And I've got a method called play, which does two jobs. The first is that it checks that the message of the player who's about to play is about to play in the right turn. So you say play, X and Y are the coordinates of the square where you're going to place a naught or an X, and then player is a naught or an X, and it checks that if you're going to play as X, it's X's turn, and if it is, then that method will push the appropriate button in the 3x3 matrix of buttons that make up the game. So having done all that preparatory work, here's an example of one of the 3 or 4 tests which were needed for the game. So X plays in square naught, naught. Python, of course, starts counting from naught, not 1. Naught plays in square naught, 1. X plays, naught plays, X plays again, and now X has played in naught, naught, 1 naught, and 2 naught. So X has got 3 in a row. And what you'd hope would happen at that stage is the message from the game would say X wins. And sure enough, when you run the test, that test passes. You really need, well, I thought just 3 tests to satisfy myself. One was looking at a win by X, one was looking by a win by naught, and the third possibility is that it might be that neither player wins, but the board has got filled up, in which case it's a draw, and you need to check that that happens correctly as well. That's worked very well, but although automated tests are great, you still sometimes need manual testing. If you're doing this professionally, one motivation for that is that developers tend to focus on getting an application to work, whereas testers tend to focus on how to get the application to fail, because it's their job to sort out remaining bugs. And in spite of all my efforts at automated testing, it turns out that the published code in the book has got a bug. It's not a very serious one, but I discovered it by doing manual testing. And the bug is this, that after one of the players has won the game, it will let you carry on and let the other player play. And so after a win, you can still carry on making moves until the board is full, at which point, of course, the game thinks it's a draw. So what do you do in that situation if you're trying to make good use of tests? If you found a bug, create a test that shows that bug operating, and then fix the bug in the application code and check that the test now passes. So here is that extra test which I added. Notice that I've tried to name the tests in a way that makes sense in terms of what I was trying to do. And what I was trying to check was that the game stops when someone wins. So I had the same series of moves that we had before, in which naught wins. And then I attempt to make 3 more moves. And previously, it would have allowed me to do that. And it would have ended up thinking that there was a draw. Now, when I run this test, the test fails because the code is still buggy. And what I need to do is write something which says, whenever somebody's won, I want to go through with the rows going from 0 to 2 and the columns going from 0 to 2. And I want for each of the push buttons to tell the button that it's now disabled. And because all of the buttons are now disabled, nobody can make any more moves. They can click all they like. It won't affect the game. And it will wait until the game gets reset again. So really pretty straightforward code there. Much, much easier to test things this way than to do it manually. If you're interested, all of the code for both the application as I've refactored it and the test code are up on GitHub. And if you're interested in exploring building applications this way, in particular, if you're interested in doing test-driven development, there's a brilliant book called Growing Object-Oriented Software Guided by Test. The only problem with it is that the book assumes that you're coding in Java, and relatively few of us are developing in Java on the Raspberry Pi. So one of the things I'm working on at the moment is looking at doing effectively a port of that book into Python, so that if you want to do Python test-driven development, you'll be able to work through some real case studies, just as the original worked. I mentioned the refactoring book by Martin Fowler, improving the design of existing code. There's also an extremely useful book if you're confronted with the kind of situation that I was, which is you're given some code and it doesn't have any tests. So how do you start applying tests so that you can change that code in order to improve it? And then the last book is not particularly Python oriented, but it's got some very good advice about how to write code that's easy to understand, easy to test, and easy to change. Clean Code by Bob Martin. Okay, any questions?
So where does your test code live? Does it live in the same package, or is it separate?
It's always a good idea to keep them separate, because if you're going to deploy the code, the last thing you want to do is ship the code with the tests with your application. There's actually a horror story about that. A long while ago, Microsoft shipped a version of Excel with all of the test code, and it ran about 10 times slower than they hoped it would. So for that reason, it's good to keep them in separate packages. And actually, let me share my screen again for a second. Oh, no, I won't, because I haven't actually done it in these examples. And the reason I haven't done it in these examples is that it makes it easier for people to run the tests. Question from Vinny, can you use Guizero with C++? Sadly, no. It's a pure Python application, which is a shame, but there you go. I'm sure there's good stuff for building GUIs in C++, but I wouldn't begin to know how to use them, I'm afraid. Oh, keeping a Q&A log, Vinny is suggesting. The trouble is that as soon as you need to rely on the tester to write stuff down, you're requiring a degree of discipline that I just don't have. And so I'm much happier with stuff that's automated. Also, of course, the kind of technique I've been talking about is the kind of thing that companies like Facebook and Google and Netflix and all the big companies use this kind of technique. And typically they will be releasing new code to production many times a day. And there's just no way that you can do manual testing that frequently of a complex application. So their sequence is you make a change, you check it in, you make sure that all the tests run, and then you ship to production. And so it's really got to be automated for that to be practical. And these days, I find I need to work that way when I'm just doing stuff for myself.
Yeah, we had that talk one time that was talking about having the automated tests when you check things into GitHub.
Mm-hmm.
That was what's the guy's name again?
Yeah, I mean, ideally, you have tests which you can run very quickly, and I'll run a full test suite before I check in every time, and I check in very frequently. But it's sometimes quite hard to do that. There's quite a bit of skill in making sure that tests run fast.
Yeah, we do use automated testing at work, but
given the work you do, I'm quite relieved to hear that, Richard, because you don't really want trains to be crashing.
Yeah, so we do, like, the safety tests that are done are automated, but then only a small percentage of them automated. Most of them have to be done manually for various legacy reasons. But the other thing that is really good with our system is it just records everything. Mm-hmm. You can play it back. So if you've done a test session, or the trains are moving in operations, this is a railway signaling for those that aren't aware. It just records everything, all the inputs, and it can stream them back to you as part of the GUI. So the GUI acts as if it's live, and you can sort of see what happened. And so if you're doing testing, it's also recording what you're doing. So then when you play it back, you can see what the system reaction is. You can't tell what the operator did, but you can tell what the system reaction is, and you can look through, see what happened.
Yeah, there are some very good tools for doing that. The trouble is that pretty well all of them are commercial, and pretty well all of them are fairly expensive.
Yeah,
which
I guess
is
the key thing is logging. We got lots of logging in your projects.
Yeah,
you can see exactly what went wrong. Cool. Any other questions? I don't know if questions are in the chat or on mute. Don't have everyone screaming at us right now, so